So what I'm going to do is I'm not going to go through the reading with a fine-tooth comb. I'm just going to hit the highlights and blast through it in about 5 minutes. And then I'll expect you to do the reading in perusal and make your annotations and make your comments. And that's where I'll answer a lot of your questions as well. Okay. So let's get started. What is statistics? And so we walk through this idea that statistics can be broken basically into two sort of branches, descriptive and inferential. Now, descriptive statistics is the process of collecting and organizing data. And we're not going to do a whole lot of that. We're not going to talk about designing an experiment and doing all this. We're going to do much more inferential statistics. That is analyzing and interpreting the data. So we're just going to give you the data set, and then we're going to say, analyze this data set. What is the mean, the median, the mode? What's the standard deviation? Are there any outliers? Is this significant? What's the normal distribution look like? What is the confidence interval for the 95% confidence? That's what we're going to be doing. So we're going to be doing a lot of inferential statistics. Okay, and so when we look at who we're measuring, who's being sampled, there's sort of a nesting of these three specific ideas. So the population is the largest group that you can make. And then inside of that population is a subset called the sample. This is usually where you collect your data, from the sample. And then the sample is composed of individuals. So an example of this would be Naomi Osaka. She's the individual, but she is a part of the Women's Tennis Association, and that is a part of all tennis players, okay? So there's this nesting of the population, and then inside of that is a subgroup called the sample, and then the sample is composed of individuals. Okay, so that's an example of who is measured. We also look at what is measured, and this breaks down again into two categories. We're going to further break down this in a little bit more, but the two are qualitative and quantitative. So qualitative describes the quality of something, like the color of an automobile or the weather pattern. Notice that these are not numerical. Okay, so there's no numbers. Like you can't say, what color is that car? And you'd say 8. Right? Like that doesn't make sense. Colors are usually words like blue, green, red. I guess you could represent the color as a hexadecimal code like they do on websites, but let's not go there. Okay, the other type is quantitative data, and this is numerical in nature, right? It's a number. It's something that can be counted, okay? The other way we can break these values up quantitatively is by discrete and continuous. So discrete values are kind of like steps. So if you think about going up steps, you're on step number 1, number 2, number 3, number 4, and there's not really a middle step, right? Like there's not a step in between 2 and 3. Okay, so discrete values are like steps, or like counting sheep, like 1 sheep, 2 sheep, 3 sheep, right? They're discrete, usually whole numbers. Continuous data set is more like going down a slide. And when you go down a slide, you make contact with every single point down that slide, or going up the slide, either way, right? And so you can have a value here at 3. You can also have a value here at 1. You can also have a value here at 2.458791, right? And you're really only limited by the accuracy of your measuring device. Okay, and so a continuous data set has an infinite number of values, all kind of strung together, where a discrete value set has discrete numbers, 1, 2, 3. Okay, and so those are examples of the type of data that we can collect. And so then we get into this, and again, this is just vocabulary. So when you do collect a sample or a data point from a sample, that is called a statistic, and we usually use Latin letters to represent those. So if you go out and you have a sample and you measure the average temperature of 10 people, that average temperature, that mean, would be represented by the letter X. Maybe it's 98.7 or something like that, okay? If you go out and measure the average temperature of everybody, which would be very difficult to do, like everybody on the planet, Like it'd take a long time to do that. And it'd probably be very inaccurate, by the way. We would call that a population, or the population is the set of people. And we would call that measurement a parameter. And it would be represented by a Greek letter. So you'd say mu is equal to 98.7. They're still the same calculation, right? You're still finding the average. You're adding them all up and dividing by how many there are. But when you're given a value like mu equals 98.7, you immediately know that that is a calculation from the entire population. When you see x equals 98.7, you know that calculation came from a sample. It's a subset of the population. Okay, so just again, vocabulary, terminology, kind of the rules of the game. We haven't started playing the game yet. We're just learning the rules right now. So here's some examples that walk through these different types of things. And then we talk about levels of measurement. And this is where we really break apart qualitative and quantitative. Okay, so there's 4 basic groups. 2 of them are qualitative. So if you have qualitative data and there's no rhyme or reason to the type of categories that you have, like the brand of a car. Okay, Ford, Chevy, Kia, Toyota. If you make a graph, maybe you put Ford first, and then Toyota, and then Kia, and then Chevy, right? And you make a little bar graph, okay? It really doesn't matter what order you put these in. You could have Ford first and Toyota second, or you could put Toyota first and Ford second, right? And obviously your graph would change a little bit, but it doesn't matter what order you display these in. A lot of times people will display them in alphabetical order or from least to greatest, but really there's no rule. It still makes sense, right? The graph still makes sense. This is called nominal data, okay? On the other hand, if you have qualitative data and there is an implied order, that's called an ordinal data set. Okay, so like shirt size, right? Small, medium, large, extra large. If I was giving you a graph of shirt size, I would probably want small first, and then medium, and then large, and then extra large, because as we progress on the graph from left to right, the sizes get larger, right? And it kind of makes sense that way. Now, there's not a number associated with these. It's not a numerical value, but there is some type of order implied in the categories. So that's ordinal data, okay? Then we look at quantitative values. So these are values that are numerical in nature. So one is interval. So you can have an interval like temperature, right? So temperature basically has an interval. If you think about like the low temperature today and the high temperature of today, there's an interval in between those, and there's numerical in nature, okay? But you really don't do any calculations with the numbers. You got numbers, you got 68 degrees Fahrenheit, but we're not really doing a calculation to get that number, right? When you do calculations, either add, subtract, multiply, and divide, those are called ratio data sets. And some of them are pretty obvious, like miles per hour. The word per means you traveled 55 miles in 1 hour, 55 miles per hour, right? And that's kind of easy because you can see that's clearly a ratio. But you could also have ratios by using other operations from mathematics: addition, subtraction, multiplication, and division. So if you multiply 2 numbers, like to find the surface area of something, and remember, to find surface area, you're kind of doing, something like maybe base times width or something like that to find the area. That would be a ratio calculation. It doesn't only have to be division. It could be multiplication as well. So the vast majority of the data that we're going to be looking at is going to be interval. It's going to be numerical in nature, and it's just going to be kind of like a single data point without a calculation in order to arrive at that number. Okay, but we just want to show you these 4. So 2 of them are nominal, 2 of them are qualitative, nominal and ordinal, and the other 2 are quantitative, interval and ratio.